everyone, we're going to solve trig equations by factoring trinomials. We're going to be using identities involving tan, secant, and cosecant, etc. So this one's a little harder than the part 1 we just did. However, this first one is probably exactly like part 1 we did. So I'm going to go ahead and just distribute the 4 here. And go ahead and write this as 1 minus sine squared of my Pythagorean identities. Now move everything over to the left side, and I'm going to get sine squared of theta plus 4 sine of theta plus 3 equals 0. I'm going to factor this, and we're going to get sine of theta plus 1 and sine of theta plus 3. You can kind of tell from the previous video that's not going to work because we don't have a sine of theta that equals -3. It doesn't make sense, so that's not possible. And so we're just going to do this one. Sine of theta equals -1. In that case, theta equals 3 pi over 2. And that's your solution. Okay, now getting into the tangent and the harder ones. We have tan squared equals 3/2 secant of theta. So the first thing I'm going to do, I want to write this in terms of secant, just like I did with sine and cosine. And I know tan squared of theta equals secant squared of theta minus 1. Then I'm going to move everything over. So I'm going to get, I'm going to multiply everything through by 2. Multiply everything through by 2. So I'm going to take this, multiply everything by 2, and that's called clearing the denominator or clearing the fractions. So you get 2 secant squared of theta minus 2 equals 3 secant of theta. Now move everything over to the left side. And go ahead and factor. And we're going to get 2 secant of theta plus 1 and secant of theta minus 2 equals 0. Whoops. So this one, we have secant of theta equals -1/2. And this one, we have secant of theta equals 2. This doesn't make any sense, so this is no solution on this side. However, here, secant, we do have angles, 2 angles where secant of theta is 2, and that is pi over 3 and 5 pi over 3. So our solution set, of course, is pi over 3 and 5 pi over 3. And the next one, similar, we're going to go ahead and write this expanded with the Pythagorean identities, which is 1 plus cotan squared of theta equals cotan of theta plus 1. I'm going to combine these. The ones will end up canceling out here. Let me do that in a different color. So you get cotan squared of theta minus cotan of theta equals 0. Remember, on quadratics, always set it to 0. I'm going to factor out a cotan of theta. You get cotan of theta minus 1 equals 0. So we have 2 different sides here. We have cotan of theta equals 0, and this one is cotan of theta equals 1. In this case, theta equals pi over 2 and 3 pi over 2. And on the right here, we have theta equals pi over 4 and 5 pi over 4. So writing this solution set from least to greatest, we have pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2. And why do you want to write it from least to greatest? Well, it makes it nice when your teacher's grading, right? So she can see everything, or he can see everything and not mark your paper. Okay. For this one, I'm going to use my double angle identity for cosine that involves sine squared, because we have a sine here. And we did this in a previous video as well. So this is going to be 1 minus 2 sine squared of theta. I'm going to move everything over to the left side because I like my, you should have your lead positive here. And then so minus sine plus 2 equals 0. Okay. If you look at this, you cannot factor this. It is quadratic in sign. If we look at the discriminant, remember the discriminant is b squared minus 4ac. In this case, my a would be 2, my b is negative 1, and my c is 2. Remember that? So this would be 1 minus 16, which equals negative 15, which is less than 0. That means there's no real solutions. Remember on the quadratic formula, if you're doing the negative b plus or minus this part, if this is negative, that means you have imaginary solutions. Remember that? So I just looked at that. I knew I couldn't factor it, so I just checked with the discriminant there. So there's no real solutions to this. Okay, the last one, I'm going to go ahead and write this in terms of cosine, the double identity, which is cosine, 2 cosine squared of theta minus 1 plus 5 cosine of theta plus 3 equals 0. Now, cleaning this up, I get 2 cosine squared of theta plus 5 cosine of theta plus 2 equals 0. Let's see if we can factor this one. Yeah, it looks like. Okay, so we have 2 cosine of theta plus 1 and cosine of theta plus 2 equals 0. Clearly, when you look at this one, you're not used to, that's not true, so not possible, so no solution. This one set to 0, we'd get cosine of theta equals negative 1/2. And therefore our theta would be 2 pi over 3 and 4 pi over 3. Therefore my solution set would be 2 pi over 3. It's just the same thing. And 4 pi over 3. Alright, the next set I'm going to do is just another set. They're a little different, and you have to deal with the identities a little bit more. So that will be the next group. Thank you, and have a nice day. Bye-bye.